Hi there, in this video we are going to go over how to identify rational numbers. Alright, to start, a rational number is any number that can be written as a fraction. Alright, so a rational number is any number that can be written as a fraction. It has the word ratio in it, so that kind of gives it away or gives you a hint that it has to do with ratios or fractions, right? A fraction is a kind of ratio. All right, so rational numbers include terminating decimals, these are decimals that end, right? So for instance, 0.2, that's a decimal that ends. Technically, it ends in zeros, right? But there are no other numbers past the 2 other than zeros. All right, terminating decimals, repeating decimals are also rational numbers, and integers. All right, repeating decimals are decimals that have repeating digits. They are shown with the bar notation. So the bar notation looks like that. It is just a bar that goes over the digit that repeats. So we have here 0.444444. That is a repeating decimal. And then integers, these are the positive and negative whole numbers that include 0. So if you were to look at a number line, they typically have your positive and negative whole numbers that include 0. So for example, -2, 0, and 4, those are integers. All right, irrational numbers are numbers that cannot be expressed as fractions. So pi, for instance, is 3.14159 and a whole bunch of other digits that we don't know. So since this cannot be written as a fraction, we don't even know the rest of the digits of pi past that, or past however many we know, we can't turn it into a fraction. Therefore, it is irrational. Same thing with 2.2360679 that I have here with the ... You see there is no pattern there. There's no repeating decimal. There's no, I shouldn't say that. There's no repeating bar, right? So that we don't know what numbers will come after that 9. So because of that, this is irrational. Okay, so if there is a repeating bar over it, then we know the rest of the digits. But because there's no repeating bar over this, we don't know the rest of the digits. All right, so therefore it's irrational. We can't turn it into a fraction. Then we have the square root of 8. Okay, square root means what number times itself will get you 8. So if you were to take the square root of 8 in your calculator, you would get about 2.828427 ... There's a whole bunch of other numbers after that. The point is, you don't have a whole number times itself that'll get you that 8. So therefore, that square root of 8 is also irrational. All right, so here are some guided examples. Determine whether each number is rational or not. So you have here -3.5. The big question is, can this be turned into a fraction, yes or no? So once we determine that, then we can say yes or no, it is rational or it is not rational. So here, this -3.5, yes, this can be turned into a fraction, right? So this would be a rational number. You can turn this into a fraction. It would be -3 and 1/2, right? 0.5 is 1/2. If you were to read this and write this using proper place value, this would be read as -3 and 5/10, which if you simplify this, that's where you would get the -3.5 from. Okay, so the next one, we have 4 slash 2. That slash means division, right? Oftentimes you will see that slash in fractions in the real world. You have to know that that means division. So here we have 4 divided by 2, and that gets us 2. So because this is a whole number, this is rational. And the first one was also rational. All right, next we have 0.2468, ... Now, just because there's a pattern, 2468, right, doesn't mean we know the digits after that 8. All right, the only time we would know the rest of the digits is if there is a repeating bar there, which there is not. So since there is no repeating bar, we can't turn this into a fraction, and so this would be irrational. D, we have 0.1 repeating. This is a repeating decimal because it has that bar notation, and we know that repeating decimals are, in fact, rational. All right, the next one we have 2/3. This is already a fraction, so it gives it away for you. This is rational. All right, and then in F we have 0.121221222. So yes, it looks like there is a pattern here, but no, we don't know that for sure. So we only know the digits that come after that last digit there if there is a repeating bar over it, which there is not. So because there is no repeating bar over it, and this decimal clearly goes on because of those 3 dots at the end, then this is irrational. We don't know what the other digits are, and therefore we can't turn this into a fraction. So then it's irrational. All right, so at this time I want you to pause the video and try the rest of these examples on your own. Okay, so by now you should have paused the video and tried these examples on your own. Let's go over them. So we have 21 divided by 7, right? This is already a fraction, therefore it's rational. It gives it away for you. But just to be extra clear, right? 21 divided by 7 is 3. That's a whole number. So again, it is rational. All right, so this next one we have -2.5. This is a terminating decimal, right? And it can be written as a fraction. -2.5 is -2.5 as a fraction, right? So therefore this is, therefore this is rational. All right, next we have 0.2 repeating. So because there is that repeating bar over it, right, this can be turned into a fraction by putting it over 9. So we have 2 9s. Therefore, this is rational. Again, going back to our definition here, a rational number includes repeating decimals. All right, next we have 0.2482647 ... So there is no repeating bar over any of these digits, therefore this is irrational. We don't know what the rest of the digits are here, so we can't turn it into a fraction. All right, and then E, we have 1.3133133331. This is irrational because there is no repeating bar over it. So even though it looks like there is a pattern here with the 3s and the 1s, doesn't mean we know for sure what will come after that 1. Therefore, this is irrational. All right, and then the last one, 8 9ths. This is a fraction, so it gives it away. Because it is a fraction, we know that this is rational, right? rational number is any number that can be turned into a fraction. In this case, it's already a fraction. All right, so that's it. Hopefully you learned how to identify rational numbers. Again, a rational number is any number that can be turned into a fraction. Anything else is irrational. All right, thank you for watching.